So how is it possible that some of the stones on the Giza Plateau in various locations are seemingly eroded in the same way as some of the stones in the temples on Malta? These stones are located in vastly different climates, and they were placed 1100 years apart in their respective constructions. What's even more baffling is the fact that the erosion that you can see on these stones in these two different locations are nearly exactly the same. But the cause of the erosion at these locations are actually quite different. So my name is Kaylee, and in this video I'm going to look into the type of erosion that occurs on the Giza Plateau that is affecting some of the limestones, and I'm going to quickly go over the type of erosion that is happening on the islands of Malta. And yeah, of course, I'm going to explain why these two different types of weathering can have the same eroding effect on the limestone. And in my research for this video, I have actually asked a geologist from the Netherlands to help me out. She was also present in Egypt during the first tour, during my stay there, and she and I looked into the eroded stones near the pyramid of Mnajdra, mostly the mortuary temple at the pyramid of Mnajdra. These stones immediately made me think of the eroded stones that I saw in Malta when I was visiting the temples there last February, and I actually wanted to figure out why they looked nearly identical. I also would like to quickly mention that we must not forget that the Sahara Desert used to be covered with the Tethys Sea, and that what we see as the Sahara Desert nowadays used to actually be the seabed of this massive sea. I mention all of this in my video about the whale fossils that have been found in the Egyptian Sahara Desert near Wadi El Hitan. I'll put a link to that video in the upper right corner and probably in the description down below as well. So you can check that out for those who are interested and want to learn more about why we found whale fossils in the Sahara Desert and, you know, a little bit about whale evolution, all that stuff. Did you actually know that whales evolved from a land animal that had previously evolved from the sea? So they went from sea animal to land animal back to sea animal? Not many people know that. Another thing that's very important to note is that limestones are actually, basically speaking, ancient seafloors or seabeds, if you will. So the limestone used to be the seafloor or the seabed. This is a very important thing to remember going into this video, especially with the knowledge that the Sahara Desert used to be the seabed of the Tethys Sea. Also, yeah, the same sea that covered the Mediterranean as well for a very long time, where Malta is located. The limestones used in these constructions are actually quite similar. So now that we know all of that and we've covered the basics, let's start the video now and go over the information that I would like to discuss. And I first want to go over the type of erosion that I've witnessed with my own eyes on the islands of Malta. So the erosion that I've witnessed is most notable on the following temples: Tahajrat, Mnajdra, Hajar-im, Gigantea. I mean, it's even noticeable on Skorba, but that's coralline limestone, but it's a lot less noticeable at the Tarjeen temples. But that's mostly due to the fact that the temple complex is quite a bit younger, and due to a high level of reconstruction and renovation that has taken place there, we don't see much of the erosion anymore. Also, many of the dolmens scattered on the islands have the same erosion pattern on them as well. Yes, also we have cat. Her name's Layla. Most people who visit Malta and these ancient temples often complain about the ugly canopies that surround the Mnajdra, Hajar-im and Tarjeen temples. But they, of course, as you can imagine, forget that these canopies have been constructed there to protect these ancient temples from the acidic rain, gusts of Mediterranean sea winds, which are quite salty and not good for the stones, and, you know, other reasons. There are more reasons than that, but I mean, those are the most important reasons for the construction of the canopies. No, they're not pretty, but they're there to protect the sites. The temple period in Malta has two distinct building phases. The first phase is the Gigantia period that started 3600 BCE and ended around 3000 BCE. And the second phase is actually known as the Targine phase that started around 3000 BCE and ended around 2500 BCE, when the Neolithic temple builders disappeared from the islands of Malta. This also immediately tells you why the Targine temples aren't eroded as much as the older temples. They were simply at least 1100 to 500 years younger than the older temples. And as I've mentioned earlier, the Targine temples have been heavily reconstructed and renovated. So for this video, I am simply going to focus on the erosion that we have found on the temples of Mnajdra, Hajar-Im and Tahajrat. Why not Gigantia, you might ask? That's even older. Well, to answer that very quickly, because I'd like to go quick in this video, the Temple of Gigantia is constructed further inland, further away from the sea, on the island of Gozo, and it doesn't have a canopy constructed above it. Therefore, the erosion found on Gigantia is occurring at a slower pace when compared to the temples of Mnajdra and Hajar-Im. Also, what you hear in the background is the litter box that my cat decided to use while I was filming. I'm unable to get that audio bit out of the video. I'm so sorry. I also am in a bit of a time crunch filming this. Forgive me. I would also like to quickly mention that I've created a video on the Mnajdra temple complex in August of 2020. I'll put the link to that as well in the video as a card in the upper right corner, and I'll put it in the description down below. That video has a lot of information about the Neolithic temple builders, the construction phases, and a lot more. I go in depth about this temple and the astronomical alignments and everything you want to know. So what's very important to understand is that the temple of Mnajdra is located on the southern cliff on the island of Malta near the town of Rendi. You can clearly see on my pictures here on the screen that I took last February how close the Temple of Mnajdra actually is located to the cliff and the Mediterranean Sea. So if there's a harsh wind and the sea gets blown up, the salty water will hit the stones. So the stones used in the construction of the Mnajdra temple complex are the harder lower coralline limestone on the exterior walls and the softer Globigerina limestone on the interior walls. As I have mentioned numerous times on this channel by now, limestone is partially soluble. This means that limestone is less resistant to erosion than most igneous rocks, although it is more resistant than most other sedimentary rocks. This is my life. This is life when you have a cat. The reason as to why limestone is partially soluble has to do with the porosity of the stone and the types of minerals found inside the stone. It is actually the stability of the minerals inside the stone that dictate how sensitive the rock is to weathering. And the higher the porosity, the higher the surface area is for the weathering. This will result in faster weathering. And of course, as you can imagine, fractures in a rock are natural weak spots that are extra prone to the weathering processes as well. Again, creates more surface areas that are prone to weathering. So the hardness or softness of a rock depends on both the lithology type and the porosity. And with lithology type, I do mean the minerals that are found inside of it. We know that the coralline limestone used in the construction of these Maltese temples was quite hard, and that the Globigerina limestone is a lot softer. This actually means that the coralline limestone is less porous and the minerals are more stable, which makes this type of stone less prone to weathering. Yes, weathering will still occur, just at a slower pace compared to the Globigerina limestone or the limestone used on the Giza Plateau. So the Globigerina limestone that we see in Malta is the gold-colored limestone, and they've used this a lot in the temples. It is actually very reminiscent of the limestone used on the Giza Plateau. This limestone contains many fossils, mostly Foraminifera globigerina, which is where the name of the limestone Globigerina comes from. So for the construction of the temples in Malta, two types of limestones were used, and we know that most of the blocks used on the Giza Plateau are also made of limestone. This is very important, for this video at least. The limestone on the Giza Plateau is known as a gray-yellow colored nummulite limestone. But wait, Kaylee, what does that mean? I'll tell you, because, I explained things. Nummulites are lenticular fossils, characterized by their numerous coils. They are shells of the fossil and also present-day protozoan nummulites, which are single-celled organisms of amoeboid protists, known as foraminifera. They are commonly found in Eocene and Miocene rocks, particularly rocks located surrounding the Mediterranean, and thus Egypt, and Malta with the Globigerina limestone, which has Foraminifera globigerina inside of them. Hey! So the Globigerina limestones in Malta and the nummulite limestones in Egypt at Giza are both very similar in their mineral type, containing a lot of calcite minerals, which makes them relatively unstable and prone to weathering, and the high porosity of these stones make them weather faster. There are different types of weathering. There's physical, chemical, and biological. Physical weathering occurs due to temperature changes, freezing and thawing, and due to waves, rain, and wind. Chemical weathering occurs due to a reaction with water, oxygen, acid, like sour or acidic rains, and lastly, a reaction with the chemical released by organisms, like an organism peeing on the rock. Animals do that. Humans probably do that as well. Ew. And lastly, we have biological weathering. This occurs due to the roots of the plants and the trees uprooting the rocks. So as I mentioned at the very start of this video, the Sahara Desert, where Egypt is located, used to be covered by the Tethys Sea that covered the area from approximately 600 million years ago until approximately 14 million years ago. This sea does get different names during different periods, but that's way too much information to put into this one video about erosion. It's not a video about the history of the Tethys Sea. I could actually make that into a video, because it starts when all the continents were still, one massive continent? Maybe. So from the information that I've given you so far, you know that the limestone used for the construction of the pyramids and some parts of the mortuary temples were once part of the seabed of the Tethys Sea, as we have found many fossilized nummulites inside these blocks. These blocks of limestone were mostly quarried from the Mokattam Formation, which is a range of hills located in southeastern Cairo. This was the most important quarry site for the limestone that was used to construct the pyramids and the mortuary temples and all that jazz. Although there are some quarry sites on the Giza Plateau itself where the limestone blocks were cut and used for building the pyramids and the mortuary temples and more as well. It's just that the Mokattam Formation is the most used quarry site. So now that we know the types of limestone used in Egypt, and we've compared that to the limestones used in Malta, we know the porosity of the stone, where the stone came from, how the limestone was even formed millions of years ago, which is very important information going further into the rest of this video. And I've given you a little bit of a quick Geology 101 class, so to say. Fun thing to note before I continue to look into the cause of the erosion at the Giza Plateau is that, normally speaking, the more time a rock is exposed to the elements, the more weathering will occur. And with that, you can assess that when rocks are buried, these weathering processes will not affect the rock as long as it is submerged in soil. This is especially important to remember when comparing the temples in Malta with the Giza Plateau, because that's what we're doing in this video. So we know that the temples in Malta have been buried for quite a very long time, and the mortuary temple at the Menkaure pyramid, just like parts of the Menkaure pyramid and other structures on the Giza Plateau, have been buried under sand for quite a while as well. We know this because, the Sphinx used to be completely covered in sand. So even though the temples on Malta, like for instance Mnajdra, is 5,600 years old, and these stones were placed there more than 5,000 years ago, and the mortuary temple at the Pyramid of Menkaure and the Pyramid of Menkaure itself were constructed 4,500 years ago, which means that the stones were placed there more than 4,000 years ago. That doesn't necessarily mean that these stones were all exposed for equally as long as these structures are old. Let that sink in. Since they were buried for quite a long time, these weathering processes did not occur, and we can't be exactly sure for how long they were buried. But we know for a fact that they were not exposed the entire time since they were constructed. They are exposed now, in modern times, and they were exposed when they were created, but in between there's a long period where these structures were buried, or at least partially buried. So now it's time to look into the cause of the erosion, because as I mentioned at the opening of this video, the cause for the erosion in these two locations is quite different. So one of the biggest differences in these two locations is the average yearly precipitation. Egypt has an average precipitation of 20 centimeters a year, while Malta has an average precipitation of 70 centimeters a year. That's more than 3 times as much. In Egypt, the weather is a lot hotter. And since the Giza Plateau is located on the edge of the desert, there can be quite strong winds, as this is an open plain with not a lot there to obstruct the winds. So the wind has free range and just blows on everything really hard. The rain, and in that mostly the acidic rains and salty seawater blown up against the rocks in Malta, are the biggest cause for the erosion that has occurred there. It's mostly the rain, the water, the acidic rain, the salty seawater, all that stuff. But if you remember correctly in the opening of this video, I mentioned that the erosion in Giza looked nearly identical to that of the erosion in Malta, while Egypt has a much lower average precipitation in a year. Which means that Egypt doesn't get the same amount of rain, and therefore acidic rain, as Malta does. So in Egypt, even though it doesn't rain a lot, the rain that does fall onto the rocks can result in slight weathering processes, which is, natural, and this will affect the rocks over time. Especially with this soft, porous type of limestone, even slight weathering will affect the rocks, and over time significantly affect the rocks. But in Egypt, there is another cause for the erosion that we see, and this is quite different than the erosion that occurs in Malta. The Sahara desert sand, the granules of sand, are quite a large grain compared to other types of sand that we find in the world. Like for instance, the beach sand in Australia or Brazil, they are much finer grained than the sand that we see in the Sahara. I know this because the Dutch beaches are covered with Sahara desert sand. We take it from Africa, we blow it on the beaches here, and it's actually a bit painful to the feet, at least for my feet, because I've got sensitive feet. So I mentioned earlier that the winds can get quite strong on the Giza Plateau because it's quite a large flat plain. These strong winds can pick up the Sahara desert sand and smash this sand against the limestone. The big grains of this sand can act like a hail in this process, and therefore it can affect the weathering processes of the limestone negatively. Think about hail hitting the stones in Malta and how much that would affect the stones. So think about the sand hitting the stones in Giza and how much the sand can act like a hail and affect the stones. As you can see on screen, the top blocks are heavily eroded at the mortuary temple of Menkaure on the Giza Plateau. The reason for this is because, one, the temple has been covered in sand for a while, so the lower blocks were buried and therefore less weathered over the millennia, which again is important to remember. And reason number two is that because these rocks laid on top, they have a larger surface area exposed to rainfall, as it does annually rain a bit in Cairo. And then, because I'm not done, there's reason number three. That's because there is a difference in the limestone used here as well. We have fine-grained limestone, which is less porous and relatively less prone to weathering, which is used more on the lower portions of the walls, while the coarse-grained limestone has large pore spaces and therefore is more prone to weathering, and these stones are laying more on the higher portions of the walls. And because they had more surface area prone to weathering, they weathered faster. And then there are blocks like these that you can actually see on the screen right now, where in the same block we have portions of coarse-grained limestone and finer-grained limestone together. This entire stone is actually affected due to weathering, but you can clearly see that the finer-grained portion of the stone is eroded more. But hey, finer-grained made the stone stronger. Well, there's a problem in this stone. This has to do with the fact that the softer marl inside the finer-grained areas erodes easier. A marl is an unconsolidated mix of fine carbonate shale sediments. Marls are actually a 2 or 3 on the Mohs hardness scale, while limestone is actually a 3 or 4. So even though the coarse limestone has more pores and should be more prone to weathering, the marls inside that stone, that area, will erode faster because it's softer. The coarse-grained limestone at Giza shows the typical weathering pattern that we have seen with limestone all over the world. They typically contain a lot of fossil fragments, like for instance foraminifera, corals or shells. The whole weathering pattern that we see on the coarse limestone has to do with the type of fossils inside as well. For instance, aragonite instead of calcite minerals. Aragonite is less stable than carbonate, which means that the fossil fragments will seep out first when the stone is affected by the weathering. This process leaves the hole patterns in limestone. These holes are then naturally enlarged by the continuous weathering. So to quickly recap, the limestones used in the construction of, for instance, the mortuary temple of Menkaure are quite soft, due to a high porosity and the type of minerals, like aragonite inside of the stone. Rain, even in small quantities, can still affect the weathering processes of the stone, especially in combination with the hard winds and coarse Sahara Desert sand that gets smashed against the limestone blocks as a hail. The combination of this makes the stones at Giza look nearly exactly identical to the stones in Malta, even though they are at least 1,000 years younger and situated in a different climate. It remains unclear how long the structures were buried under sand or soil, but I personally believe that the temples in Malta were buried for a shorter period of time. Rain, even in small quantities, can still affect the weathering processes of the stone, especially in combination with the hard winds and the coarse Sahara Desert sand that gets smashed against the limestone blocks like a hail. The combination of this makes the stones at Giza look nearly identical to the stones in Malta, even though they are at least 1,000 years younger and situated in quite a different climate. So it remains unclear how long the structures were buried under sand or soil, but I personally believe that the temples in Malta were buried for a shorter period of time. My reasoning for that is that the desert sand can quickly cover a very large area, and structures are known to completely disappear in not even a long period of time. People were living on top of temples because the temples were completely buried for hundreds of years, maybe even thousands of years. While in Malta, it would have taken a lot longer for the structures to become naturally buried, and therefore I believe that they were exposed to the elements and therefore weathering for a lot longer. The stones in Malta have experienced a lot more acidic rains compared to the stones in Egypt. This is because Malta has higher annual precipitation, which affects the stone more as well. And they've experienced this for a lot longer. So this makes these stones weather more, you'd think. This actually leads me to believe that the sand, in combination with the wind, is the biggest culprit when it comes to the erosion on the Giza Plateau. The bigger grains of the Sahara Desert sand being smashed into these stones as a hail, and the sand that acts like a hail has affected the stones equally as much in a shorter time span than the rain has affected the stones in Malta in a longer time span. And to me, that shows that the sand is the biggest culprit. But this leaves me to ask you, what do you believe? What do you think happened with the stones on the Giza Plateau in comparison to the ones in Malta, now that you've got all the information? So let me know your answers in the comments down below. And if you enjoyed watching, then don't forget to give it a thumbs up, subscribe if you'd like to see more of these kind of videos, and click that bell icon if you want to be notified whenever I upload. If you haven't seen my previous videos yet, then don't make me cry into a corner, but click the card in the upper right corner, or click a link in the description down below to one of my playlists, or click a video in the end card. YouTube caters to you and whatever it is that you'd like to see. I would also like to say a massive thank you to all my patrons and my channel members. Thank you so much for supporting me. I'm eternally grateful. And if you are considering supporting me, you can either go to patreon.com/historywithkaylee or become a channel member here on the channel. And yeah, with that said, this is the end of the video. I'm back from Egypt. I'm still very tired, and I'm probably going to do one video a week for the upcoming 2, maybe 3 weeks, and then I'll roll back into 2 videos a week, depending on if I can find a quick video idea as well. But yeah, see you in the next one. Bye!